it's more complicated than this, though. You can't just look at the amounts of carbon dioxide in the air. You also have to, compared to other gases, you also have to understand like how much infrared radiation they absorb. Every different vibrational mode and these different bonds and these different molecules will absorb different amounts and infrared radiation at different wavelengths, different amounts and different wavelengths. And so, in order to really understand, how much these different gases affect global warming, then you have to have this global warming potential. It's like a comparison value for how much, what the factor of the absorption is for these different gases. Okay, so different gases have different global warming potentials, and this number represents the relative contribution of a molecule to the atmospheric gas, to global warming. All right, and so it has a fact. Everything's compared to carbon dioxide based on the amount of infrared radiation that carbon dioxide absorbs. And so what you see is the GWP, the global warming potential, is actually greater for methane and then much greater for nitrous oxide. It means it absorbs more infrared radiation per molecule. But if you also need to compare the factor, the GWP factor, with the concentration, and to figure out which is which gas contributes more to global warming, what you have to do is take the GWP and multiply it by the concentration, okay? And so you get a number that you can really compare, which of these gases contributes more to global warming. And so 1 times 385 is 385. 23 times 1.8 is 41.4. And 296 times 0.31 is 91.76. So even though the concentration of methane is greater than nitrous oxide is more of a factor to global warming because it absorbs so much more infrared radiation per molecule. But still, even though the global warming potential for carbon dioxide is less, the concentration is so much more. So still, the maximum effect factor, or the maximum gas that affects the global warming the most, when you compare these three gases, is carbon dioxide. Now, water has a very high concentration in the atmosphere, and it has a high global warming potential. It absorbs more infrared radiation than carbon dioxide. But water is not listed here, nor is it talked about, because the concentration of water is so variable, and it lasts for such a short amount of time compared to these other gases in the atmosphere, because it's literally cycled in and out, and the concentration of water varies widely depending on where you are, in a very arid region or a very humid region. So water is just too complicated to try to figure out its effect on global warming, so it's left out of a lot of these more simple models. Okay. All right, so now you can see this is part of the reason why we talk so much about carbon dioxide, because it is the gas with the largest effect that can be studied, that also is produced by humans.